This is gonna blow your mind. In 2000, John Titor, claiming to be a time traveler from 2036, posted online, predicting events like civil unrest in the US, sparking debates and conspiracy theories that persist today. To understand it and time travel, see the full video. Albert Einstein, the revolutionary physicist, forever changed our understanding of time and space. His groundbreaking theory of special relativity, published in 1905, proposed that time is not absolute but rather relative to the observer's motion. This means that time can speed up or slow down depending on how fast you're moving relative to someone else. One of the most mind-boggling consequences of special relativity is time dilation. This phenomenon predicts that time slows down for objects in motion relative to a stationary observer. The faster an object moves, the slower time passes for it. While this effect is negligible at everyday speeds, it becomes increasingly significant as we approach the speed of light. But Einstein didn't stop there. In 1915, he presented his theory of general relativity, which further revolutionized our understanding of gravity. General relativity describes gravity not as a force but as a curvature in the fabric of space-time caused by the presence of mass and energy. This curvature affects not only spatial dimensions but also the flow of time itself. One of the most intriguing implications of Einstein's theories is the possibility of time travel to the future. Time dilation, as predicted by special relativity, offers a one-way ticket to the future. If we could travel at speeds approaching the speed of light, time would slow down significantly for us relative to someone on Earth. Imagine embarking on a journey aboard a spaceship capable of reaching near light speeds. As you approach the speed of light, time would stretch and warp around you. Years might pass on Earth while you experience only a few weeks or months aboard the spaceship. Upon your return, you would have effectively leaped into the future. But what about traveling to the past? While special relativity hints at the possibility of time dilation, it doesn't provide a clear mechanism for reversing the arrow of time. To explore the possibility of backward time travel, we need to venture further into the realm of theoretical physics. The concept of traveling to the past raises a plethora of paradoxes, the most famous of which is the grandfather paradox. Imagine traveling back in time and accidentally killing your grandfather before your parent was born. This seemingly simple act creates a logical inconsistency. If your grandfather died before your parent was born, then you wouldn't exist to travel back in time in the first place. The grandfather paradox highlights the potential for causality violations in time travel scenarios. If we could alter the past, wouldn't we risk unraveling the very fabric of reality as we know it? This paradox has puzzled physicists and philosophers for decades, leading to various hypotheses attempting to reconcile time travel with our understanding of causality. Some theories suggest that time travel to the past might be possible, but that any attempts to alter the past would be met with some form of self-correcting mechanism. For instance, perhaps any actions taken in the past would automatically lead to a consistent future, preventing any paradoxes from arising. While time dilation offers a glimpse into the future, wormholes provide a more tantalizing possibility: shortcuts through the fabric of space-time that could potentially connect distant points in both space and time. These hypothetical tunnels, predicted by Einstein's equations of general relativity, could theoretically allow for faster-than-light travel and even time travel. Imagine space-time as a sheet of paper folded in half, with two distant points marked on its surface. A wormhole would be like a tunnel connecting those 2 points, creating a shortcut through the fabric of space-time. By traversing this tunnel, one could theoretically travel vast distances in a much shorter amount of time than it would take to travel through conventional space-time. However, wormholes remain highly speculative entities. Their existence has not been confirmed, and even if they do exist, the technology required to create, stabilize, and traverse them is far beyond our current capabilities. Nonetheless, the concept of wormholes continues to captivate the imaginations of scientists and science fiction enthusiasts alike. The Tipler cylinder, proposed by mathematician Frank Tipler in 1974, presents another intriguing, albeit highly speculative, concept for achieving time travel. This hypothetical megastructure involves a massive, infinitely long cylinder rotating at near-light speeds. The intense gravitational forces generated by this spinning cylinder would warp space-time to such an extent that it would create closed, time-like curves, essentially loops in the fabric of space-time. According to Tipler's calculations, an object following a specific trajectory around a rotating Tipler cylinder could theoretically travel back in time. However, the construction of such a megastructure presents enormous engineering challenges, not to mention the astronomical amounts of energy required to power it. While the Tipler cylinder remains firmly in the realm of theoretical physics, it highlights the profound implications of Einstein's theories and the potential for manipulating gravity to achieve seemingly impossible feats such as time travel. Time travel in fiction, from H.G. Wells to the distant future. Time travel has been a staple of science fiction literature and film for over a century. From H.G. Wells's groundbreaking novel The Time Machine to the iconic DeLorean in Back to the Future, time travel has served as a plot device for exploring alternate timelines, paradoxes, and the consequences of tampering with the past or future. Science fiction often uses time travel to examine philosophical and ethical dilemmas, such as the butterfly effect, where small changes in the past can have significant and unforeseen consequences in the future. It also provides a platform for exploring the nature of time itself, free will versus determinism, and the potential impact of technology on human destiny. While science fiction often takes creative liberties with the science of time travel, it serves as a powerful tool for stimulating our imaginations and prompting us to contemplate the possibilities and implications of this mind-boggling concept. Myths and legends. Whispers of time travel through the ages. Long before the advent of modern physics, ancient cultures grappled with the concept of time through myths, legends, and religious texts. Tales of time travel or temporal distortions appear in various forms across different cultures, suggesting a timeless fascination with manipulating the flow of time. In Hindu mythology, the epic Mahabharata describes King Raivata's journey to the heavens, where he meets the creator god Brahma. Upon his return to Earth, Raivata discovers that eons have passed, highlighting the relative nature of time in Hindu cosmology. Similarly, Japanese folklore features the tale of Urashima Taro, a fisherman who spends what he believes is a few days in an underwater palace, only to return to his village centuries later. While these myths and legends should not be interpreted as literal accounts of time travel, they offer a glimpse into our ancestors' efforts to comprehend the passage of time and the mysteries of the cosmos. The quest for temporal mastery, challenges and ethical dilemmas. Despite centuries of fascination and scientific inquiry, time travel remains an elusive dream. The challenges of achieving time travel are immense, requiring breakthroughs in our understanding of physics, the development of revolutionary technologies, and perhaps even a fundamental shift in our perception of reality. Even if we were to overcome these technological hurdles, the ethical implications of time travel would be profound. The potential for altering the past or future raises concerns about unintended consequences, paradoxes, and the very nature of free will. Who would have the authority to control time travel technology, and what safeguards would need to be in place? As we continue to explore the mysteries of time travel, we must proceed with caution, recognizing both the potential benefits and the profound ethical considerations that come with tampering with the very fabric of space-time. The unknowable future. Will we ever conquer time? The question of whether or not time travel will ever be possible remains one of the most tantalizing mysteries of our universe. While Einstein's theories provide a framework for understanding the nature of time, they also highlight the immense challenges and paradoxes associated with manipulating it. Perhaps time travel will forever remain in the realm of science fiction, a testament to the boundless capacity of the human imagination. Or perhaps as our understanding of the cosmos deepens and our technological prowess advances, we will one day unlock the secrets of time travel, ushering in an era where the boundaries of past, present, and future become intriguingly blurred. Only time will tell. Time.